Okay, welcome back to THS Chemistry. Today we're talking about ground state electrons versus excited state electrons. And you gotta know how to tell the difference between the two states. You have to be able to recognize electron configurations for both. Okay, first of all, ground state, what is it? Ground state electron configuration is the lowest energy an atom's electrons can have. Okay, so they always fill from the lowest possible energy level upwards. In the New York State reference tables, you're going to need these, so take these out. All right, hit pause, take them out. You need to flip to your periodic table. Okay, electron configurations are listed for atoms in the ground state on the periodic table. Remember, atoms are neutral. They have the same number of protons and electrons. So, for oxygen, oxygen has 8 electrons. Okay, it's atomic number 8. Look at right below the atomic number for oxygen. See the 8? Look right below it. The electron configuration is 2,6. Right? The reason why is there's 2 electrons in the first energy level, and there's 2 in the first energy level and 6 in the second energy level. Together they make 8. Okay? So what is the ground state configuration for AR? Okay, find AR, write down the electron configuration for AR. Okay. Energy levels. All right, there's 7 principal energy levels. The first energy level can hold 2 electrons. Okay, you can have less, but you can't have more than 2. So you never have 3 electrons in the first energy level. It's always 2. You can't have more than 2. The second energy level can hold 8. The third energy level can hold 18. And the fourth through the 7th, the rest of them hold 32. All right, there is exceptions to the order that they fill. You don't always fill the first, go to second, second goes to third, third goes to fourth, fourth goes to fifth. All right. They do not fill the third level before going to the fourth. All right. However, you do fill the first and the second levels before you go to the third. So you always fill the first and second levels first. All right. So we'll take a look at the first 10 electrons here. All right. Ground state configurations for the first 10 atoms. H. Notice the atomic number is 1. It has 1 electron. So the electron configuration is just 1. All right, He, number 2. Electron configuration is 2. So that means there's 2 electrons in the first energy level. All right, lithium has 3 electrons. So we only can put 2 electrons in the first energy level. So the electron configuration for Li is 2, 1. Total 3, right? Be is 2, 2. Totals 4 electrons. There's 2 in the first energy level, 2 in the second energy level. All right, and so on. So I have 5 electrons, it's 2, 3. 6 is 2, 4. 7 is 2, 5. 8 is 2, 6. All right, fluorine is atomic number 9. How many electrons does fluorine have? 9. So what would the configuration be? Look it up if you don't get it. Should be 2, 7. All right, neon would be 2, 8. Okay, so the first 18 electrons fill in order. Then we run into an exception. Okay, where the exception starts is on number 19. Okay, so argon was 288. That means there's 2 electrons in the first energy level, there's 8 in the second energy level, and 8 in the third energy level. Okay. Element 19, potassium, is 2881. That means there's 8 in the third and 1 in the fourth. However, we did not fill the third level completely. The reason why is this. Each energy level has sublevels. It's like the high school. It has three floors. On the third floor, there's different rooms. So some of you guys are in 328. Some guys are in 323. Well, those are like the sublevels. So each energy level has a sublevel. So the electrons are in different sublevels. When we start to get to higher energy levels, some of these sublevels start to overlap. So technically the fourth energy level, one of the sublevels, the S sublevel, is lower in energy than the third energy level's D sublevel. Okay, so energy is increasing here. It goes 1s2, 2s2, 2p6. Notice how there's 2 in the first, 8 in the second. Well, there's the first 8 electrons in the third are lower in energy than the fourth electron level. It's 2 electrons. Then the rest of the 3 comes after the first 2 electrons in the fourth. So if we're talking about sublevels, right, the order starts to matter. Okay, what you guys need to do is be able to recognize that this is the ground state for K, because you can look it up in your reference table and know that 2881 is the ground state for potassium. Okay? Okay, excited state. Now, the difference between excited state and ground state is energy. So when an electron in an atom gains a specific amount of energy, the electron is at a higher energy state. That means the excited state. The electron is said to jump to a higher energy levels. That means you don't gain electrons here. All it means is the electrons that you have, some of them have gained enough energy to go to a higher energy level, like going from 2 to 3 or 2 to 4 or 3 to 5. You're jumping up in energy levels. All right, you need to be able to distinguish between ground state and excited state electron configurations. Okay, this is the whole point. They asked a lot of questions on this. So, you know, for example, magnesium. Atomic number is 12, so you have 12 electrons. All right, so the ground state, look it up. If you don't know it, it's 282. 2 in the first, 8 in the second, 2 in the third. See how they add up to 12? Okay, so the excited state possibilities could be 273, 183, 2811. Okay, those are all possibilities there, because notice how they all add up to what? Well, 12, yeah, right. So 12 is the amount of electrons in a magnesium atom. So your excited state needs to add up to that quantity. So excited state still equals the same number of electrons in the atom, just not in the same order as the ground state. Okay? So the 273, one of the electrons from the second level, jumped to the third. In the 183 combination, one of the electrons from the first energy level jumped to the third. In the 2811 combo, one electron from the third jumped to the fourth. Okay, so excited state, same number of electrons, it's just out of order. So what element would have the excited state 277? So what's the total electrons you got there? 16, good. So what atom has 16 electrons? All right, so write that down. So that's the difference between excited state and ground state. It's the order the order that they're in, sorry. So the order they're in determines how many electrons you have, and that will tell you what atom you're dealing with. Okay, the excited state is out of order. Ground state is in the ground state because it's in the correct lowest energy order that's on the reference table. All right, have a good day. See you soon.